keyboard on this computer. There we go. Okay. So I'm going to, let's see. In case you're curious, yes, I did update to Windows 11 here because I wanted to try it out. And so far, it hasn't crashed. So, all right, so let's go IntelliJ, boom, got our thing over here. Now what I'm going to do is I'm going to drag all these into the project, refactor, boom. All right, now I'm going to select all these, except for that one, because that's not it. Right click. And let's see, I believe that add as library. Right, now so for other ones, it might be along the lines of add to build path. Again, for the specifics of how you do that, you should check out your video on the appropriate, because I did one for NetBeans, I did one for so I did one for NetBeans, I did one for Eclipse, and I did one for IntelliJ. So I figured I'd hit all the main bases here. But that basically, what I just did there basically says, hey, these random files here, you should look at them and use them as libraries. Thanks, IDE. So now I'm going to create my example class over here. So this is and the main point of this is so that you aren't going into the final assignment basically without any tools. Okay? Because that one, I don't want you to have to think about the tools. I want you to use the tools. Okay. So what we got here? We want a PSVM, public static void main, and let's test this by creating a graph. Now, if I type, notice it came up. Graph VE, not from java.something, but from the package edu.uci.ics.jung. So big import path, but there we go. We've got a graph. And so just like hash maps, graphs can say, basically what we're doing is that, remember, graphs have vertices and they have edges, or sometimes we call them nodes and edges. And I like calling them nodes because that's less syllables and it's shorter to spell. But you can use any kind of object to represent either of those. So I'll just simply use, I like to use strings to represent both. I'm going to use a string and I'll use an integer and a string. Integer, and string for both, whatever. Doesn't really matter. So, because I like them to be names and stuff. So what we're going to do is that we are going to then say this is graph is equal to new sparse, and then we need to say what kind of graph we want. I'm going to say a new sparse graph. Now, there are sparse graph, just like you have array lists and linked lists. There are different ways we would want to maybe organize our graphs. Hold on one second. So there's two different ways to organize our graphs, and the reason I'm bringing it up is because this is kind of important for the final exam. Speaking of final exam, we'll do a review session on Friday. I can also do a review session during the study day for you guys, non-mandatory, but I can also spend that going over the final exam as well, since just because of the way the semester is structured for you guys. Would you want me to do that?
That would be great.
Great. So now, unlike the other final, so here's the thing, unlike the other final exams or other exams, I don't write a practice final for this one. Instead, what I like to do is I like to go and look at other schools' practice finals as well as other schools' actual final exams that are old final exams, and basically say, okay, so what do we know here? Can we translate what they have to what we have? And those kind of things. And it ends up being a rewarding, at least intellectually rewarding experience of sorts. So what we're going to do is So I'll figure more about that on your Friday. So let's talk. And then once this is done, I'll look up the final date and I'll send it out as an announcement, and just so we all know when it is. So, okay. So we've got our graph. Now we have a sparse graph here. Now that just means that this is a graph where basically we're expecting this, the same order of magnitude for nodes and edges. If you have n nodes, you can have a possible n squared edges, right? Because you can have every pair of nodes can have a single edge between them. So what does that mean for us? So a sparse graph is just going to use essentially a linked list kind of structure or a hash map kind of structure to do this. Really depends, but basically it's using a linked based structure of some sort, just to kind of keep track of all, to say, hey, this node has all these things as edges. So what are we going to do here? We are going to but anyway, we've got kind of confirmation that's working here, okay? And then we can add things to it. Like we can go graph.addEdge and given an edge and our vertice and another vertice, it'll tell us. Now the edge names the names of anything you enter into this should be unique. Okay. So, but again, there's a very good tutorial that is on here. So let me go ahead and point you to that. Right. So go back to Jung where we found it. Right. If you go over to examples, I think that's blank. Yeah, never mind. Not examples. Documentation. Tutorial. Yeah, there we go. Jung 2.0 tutorial. So basically, it's just we give you a pretty much a functional program over here, and we can run it. And you know what? I'll just simply grab it over here. And let's go ahead, and I'm going to just dump it in here. So it should. Okay, ostensibly, it does not work because, of course, it is an abomination here. Okay, so let's go ahead and, okay. So there. This casting they don't really need to do. By default, we are using undirected edges, meaning that basically if you've got a connection between A to B, you can also use that connection to get from B to A, which is pretty cool. So now what's cool about this is that you can basically just use this as is, like this. So here. So let's go ahead and, so we can just use this as is. I'm going to go ahead. Now a multigraph means you can have multiple edges between two nodes, which that's cool. But when we're doing but pretty much all the graphs in your undergraduate curriculum are going to be simple graphs because most graphs are simple graphs, not multigraphs. So now we run it, and you can see that basically we've got a graph G, edges are 1, 2, 3, and we have edge B between 2 and 3, and edge A between 1 and 2. Those are so basically this is the built-in two-string method. So it's a very useful built-in two-string method. Now we can use the same nodes and edges in two different graphs. So that's cool as well. So here we can create a second graph. Sorry about this. It's taking a bit, but I promise I'll make it up to you to just kind of get a better idea of this. So boom. Okay, edge type, Alt Enter. this is saying that, hey, create a directed edge. You won't need to do that because I mean the edges you're going to be working with are most likely going to be there. So, you know, we can have one graph, we can have another graph, which is pretty cool. But the other thing is that we can also have code here that can, if you follow some of the directions here, you can do actually graphical output. Like that would be something that your code will print, or it will come up with a window and automatically lay out all the nodes for you so you can visualize what you're doing. So for this, I want you to implement depth first search and breadth first search. And the way I suggest doing that is for breadth first search, you definitely don't want to make it for depth first search, you don't want to make that recursive. And instead, what you're going to want to do is something like this. Public static. And remember, I'm going to make this generic so that I don't have to worry about the types in the graph. Okay. Public static VE. We can either do a void or a string to return, whatever. But what I want is like the output in which I want to know what the order in which things were returned in. So we could do a list. It doesn't really matter. Public static void BFS. Here's where most students kind of get tripped up on. It's like, okay, we want to do depth first search on a graph which has these vertices and edges, right? But what in the world? But now I'm here. Where's my starting point? Great question. So you can either just randomly choose a node, which seems not that scientific and pretty random. But instead, what I suggest for each of these is to have a vertice, is to have a starting vertice just defined and passed in, if that makes sense, right? So pass in the graph you want to use, pass in a starting point that you want to use. Make sense to everybody? Now, as well, what you'll want to do is, there's one more trick that's not necessarily obvious. So like, say you want to get like the first, like, so first off, you can say, hey, give me a, you know, sorry. So we can add edges, we can add vertices, we can get endpoints. You also have contains edge, contains vertice. There's also get edge count, which gets the number of edges, right? So these are useful kind of things for loops. Get neighbors is possibly the biggest one that's our, so a neighbor is anybody who's got a connection with me. So if you've got get neighbors, right, I can write a for loop of something like, so say I've got some vertice that I want to look at all the neighbors of, okay? Being target is equal to null. This will be a null pointer expression exception if I actually try to do it, but I wanted to create a variable. So for each v neighbor of in g dot get neighbors of target. So for every neighbor, so this will iterate through all my neighbors, so I can see who's one step away from me. So this is pretty cool for what you need to use. Another thing that's pretty cool, pretty good to use is you can do dot to get. You can do get edges. You can also do get vertices, which returns all the vertices if you ever need that. And if you need ever like just choose one from it, you can always remember if you're like, gee, it's a collection, I don't know what to do with it. Any collection can be turned into an array like this. To array, boom, you're done. It's an array now if you need it. So at this point, it's pretty much possible for you to transform any. So if you're stuck because you don't know what data structure to use or how to use the data structure here, you can always change the data structure you're using just by simply transforming it from one to another or taking all the things and adding it. So what I want you to do is implement depth first search and breadth first search. They're fairly straightforward functions you can find on Wikipedia. Stop sharing and stop.